Solve the equation log of 5x plus 2 minus 1 equals log of 2x minus 1. We have a log equation, so first let's check for restrictions. Remember that for logs, we can't have 0 or negative inside the log. That means for this first term, we need to make sure the inside, 5x plus 2, is greater than 0. Let's solve for x. We subtract 2 from both sides of the equation, which leaves us with 5x greater than negative 2. Then we divide both sides by 5. We get that x is greater than negative 2/5. Let's check the second log. We need to make sure the inside of this is also not negative. So we need 2x minus 1 to be greater than 0. Just like before, we're going to solve for x. So we add 1 to both sides of the equation, giving us 2x is greater than 1. Then we divide both sides by 2. This tells us x must be greater than 1/2. Now we have two sets of restrictions. We need these both to be true. So it may help to draw a number line to get an idea of what this means. So I'm going to plot both of these numbers on a number line. We have negative 2/5 and we have 1/2. From this first condition here, we know that x must be greater than 2/5. So that means we start at 2/5 and we shade in everything to the right. The second restriction says x is greater than 1/2. That means we start out with at x equals 1/2 and shade in everything to the right. Now we want to look at what's the most restrictive set we can here, and that'll be the one in red. X is greater than 1/2. Because if x is greater than 1/2, any values that are greater than 1/2 to the right are also to the right of negative 2/5. So that says any solutions we have to be greater than 1/2. Now let's solve the equation. We have logs on both sides, which means the first thing we want to do is get all the logs on one side of the equation and all the non-logs on the other side. So I'll start by subtracting log of 2x minus 1 from both sides of the equation. While we're at it, let's also get rid of this non-log. Let's add 1 to both sides of the equation. This way, on the right-hand side, the logs cancel out. We're left with just 1. On the left, the 1's cancel out, and we're left with the logs. Now we want to use the log properties to combine all of our logs into a single term. We have a subtraction, so we can write this as a single log with a division on the inside. Log of 5x plus 2 divided by 2x minus 1 equals 1. Now there's no base written here, so the base is understood to be 10. Let's now switch this from log form to exponential form. This is where we keep the base, and then these two switch roles. So the 1 becomes the exponent. This inside, this fraction, becomes the right-hand side. Okay, so now we've got an equation with no logs. 10 to the first is just 10, or 10 over 1. We can now cross multiply to get rid of the fractions. So this gives us, multiplying these two together, we've got 20x minus 10 equals, multiplying these two together, 5x plus 2. We want to get x by itself, so now let's subtract 5x from both sides of the equation to move all the logs to the left-hand side, and all the non-logs will move to the right. So let's go and add 10 to both sides. So on the left, the 10's cancel. On the right, the 5x's cancel. If we combine like terms, we've got 15x on the left-hand side and 12 on the right-hand side. Finally, we'll divide both sides by 15 to get x by itself. So on the left, these reduce to give us just x. On the right, we can reduce also because these both have a 3 in common. So we can reduce this to 4/5. And finally, checking to make sure this is okay with our restrictions, 4/5 is greater than 1/2. And so we know we're going to accept this answer. X equals 4/5.